Hello everyone, welcome to another video from EGIS Associates. We're still here at the North Carolina GIS Conference in Winston-Salem, and I'm here in the Duncan Parnell booth and want to talk about field data collection, technologies that have come about, and kind of why are we still doing this? We've been collecting data for a long time. I started out as a land surveyor, and I remember going out and doing collection on sanitary sewer systems and water systems and road networks and all that. Yet we're still out there collecting, and a lot of things have changed. I remember pulling a chain and using a transit and then getting into a total station and then taking that into GPS, and now we have LiDAR and drones and a lot of things, and of course everything is GPS enabled. I think my refrigerator is now GPS enabled. So we just thought we'd get kind of an idea of what y'all are seeing as one of the premier Trimble dealers, especially here in the Southeast U.S. I know y'all are well respected and well trusted in the industry. We've bought some equipment from y'all for when I was with a previous employer. So we'll just go from there. So if you'll introduce yourself real quick, and then we'll get the discussion going.
Okay. Thank you, Trip, and I certainly appreciate the opportunity to visit with you today. My name is York Groh. I'm the mapping product manager for Duncan Parnell. We cover a 8-state region now here in the Southeast. I physically am located up in Virginia, out of our Richmond, Virginia office, but I kind of manage some other salespeople and things like that. And we've certainly seen lots of changes over the past few years in what people are using in the field, and we anticipate those changes continuing. It is kind of interesting to me as well that people are still needing to map things, but I think a lot of it has to do with infrastructure. Your infrastructure is getting older, especially here in the South and the Southeast, so that water lines that were put in 50 years ago or even 20 years ago, technologies are changing so that we can have better types of facilities that are put in the ground. Plus things are breaking that were put in the ground 50 or 60 years ago. So when new installations are put in, we need to know where those things are. So we need to know not only where they are horizontally, but where they are vertically. Because there are plenty of times where a sewer line may go in, on top of that goes a water line, and somewhere associated with that is a fiber optic line. So knowing where those are and knowing where those are precisely becomes increasingly important. As our populations increase, as cities densify and people want more and more, they want better electricity, they want faster internet, all that requires infrastructure, whether it's better roads, whatever it is. And so those changes require us to keep up with those changes in what's out there on the ground, so we still need to map things. And I think we're slowly seeing lots of changes in the way we collect data. Traditionally it was going out with a traditional handheld to go collect things, and the reality is this form factor is still very popular. But now in the field, everybody's using their phone.
Yep.
Not only to talk to my boss and so I can keep up with my field workers, but now why can't I use this to collect all my data? So that's where we've seen a lot of transition now, is people wanting to use their phones or a tablet type device to keep up with that. So various manufacturers, including Trimble, have come up with receivers that interact with a phone, so that now instead of having to use a handheld product that's just a GPS receiver, now I can use something I'm using for workflows for lots of applications. Now it can do my high accuracy GPS as well.
So, you mentioned the whole knowing where things are vertically. And I think that's a big shift in thinking within the GIS realms, especially, surveying and engineering, we've always kind of thought in that 3D world because we've have to for design purposes. But in GIS, we've just been laying things on a 2D map. How have you seen the impact of the need to go 3D in GIS in pushing folks to try newer technologies, more robust data collection techniques and equipment, so that we are getting accurate data collection? Because that's always kind of been a problem with the handheld unit, right? You're holding your hand, you don't get accurate verticals because you're holding it here, down here, whatever. So how is that driving kind of the change or the shift in the types of equipment that people are buying? And then also, how are they in turn trying to justify that? Because you go into a city council, a county commission, and try to justify the purchase of a new unit, and like you said, everybody's phone has GPS on it. So how are you able to explain it to them? And because I've done that too. I walked in and, hey, you got to have this, and they're, why? I can just go to and use my phone and collect it, right? So how are y'all addressing those things?
Sure. So I think that's where the interface between different disciplines is really important. You mentioned that you came from a surveying background, and surveyors usually were left to do their thing. So that a consultant, a municipality said, well, we need to build something. Well, we got to design it first. So that was given to the engineers and really the surveyors to go design something. Well, now when I'm a utility worker and I'm going to go put a new line in the ground, or I'm building something new, and from a planning perspective I need to plan it, well, I've got to be able to plan with a different level of accuracy than what I used to, because there's so much other stuff in the ground out there. We did a talk yesterday with the city of Greensboro where we did some testing with a piece of equipment, and the gentleman we worked with was a GIS manager. He was not a surveyor, he was not an engineer, but yet he's responsible for keeping up with that information in both a horizontal and a vertical. I remember one graphic or a picture he showed of an open hole they had in the ground, and there were probably 4 or 5 different pipes in that one hole that he showed because of the infrastructure that was under there. So as a GIS manager, he's now responsible for that information, and that example showed that vertical is just as important as horizontal. The other thing that's happened is the ability to collect at high precision levels has gotten easier. In the past, it required a surveyor to go collect that level of accuracy because of the equipment that needed to be used, and the carefulness or the methodicalness of using that equipment was required. Now, I can take this little ball, I can throw it on top of a rod, and suddenly I've gotten this level of accuracy due to advances in technology. That's a great thing as long as you understand the parameters it works under. So what we've seen a lot in the GIS world is a need for GIS professionals to understand datums, to understand ellipsoid heights and mean sea levels and orthometric heights, and what does all that mean? Traditionally we've left out to the surveying community, and they've done a great job of handling all that. But now when we interface the GIS community, that requires GIS professionals as well as manufacturers like Esri to compensate for those different models inside of their systems so that we can keep track of it. Because yes, I may be able to use this and get within 1.5 to 2 centimeters on the vertical, but if I'm not interpreting that through the same lens that my engineer is and that the person who's putting the pipe in the ground is, then it doesn't really matter how accurate it is. So interpreting that information. So back to your question of how do we justify to a board of supervisors that we need this level of equipment, I think a lot of it is because we can, meaning that we don't have to outsource now everything we do to a surveyor or to an outside engineering firm. We can now do some of these things in-house, but we have to have the resources to do that in-house. So sometimes it's a budgetary observation of, if I bring it in-house, here's how much money I can save, rather than having to let a contract to go have that done. Those are the kinds of things that we've seen in the field.
So, very good. You mentioned datums, and that's one of my pet peeves. I'm big on coordinate systems and datums and all the parts. And it's really, for something that's such a key part of what we do, it's amazing to me how little our people in GIS, as well as surveyors and engineers, don't understand that stuff. All they know is, oh, it's in state plane, or UTM or whatever. We do have in 2022 a new datum coming in that's going to be both a horizontal and a vertical datum. Here in the U.S., other countries, I know Australia also has a similar new datum coming over there, because they literally, their whole country being has shifted like 7 feet or more since their original datums were established. Based on what you know with the Trimble product line as well as others, are they ready for that new datum? And what would you suggest to your existing user base or other GIS people out there, how to prepare for the new datum that's coming?
That's a great question. It's been talked about much in the past few years, and National Geodetic Survey is doing a great job of evangelizing that, if you will, of what's going to be going on. The problem, I don't think, is in the fact that we're going to have a new datum. The hardware will be able to take care of it. The software will be able to take care of that new datum. The challenge will become in the transformations that must take place between the new and the old. That's where the rub comes in.
Yep.
You know, I've got customers in some rural parts, especially in the natural gas industry in West Virginia. They're still using NAD 27, and it chokes me when I understand that's what they're still doing, but they are. Mm-hmm. And because they just haven't made that transition over to even a NAD 83. Mm-hmm. And now here we go, we're going to have a 2020 that'll be adopted in 2022. So the challenge is not that we have a new datum. The challenge is how do we transform existing information into the new information, and where do those transformations take place? And that's where decisions will have to be made by GIS managers of municipalities, of engineering firms and things like that, to understand enough so they can say, yes, we're going to make that change. And then they're going to have to allot budgetary time for the GIS manager to say, okay, I've got to spend the next 2 months making certain that we've now transposed all of our information from the old datum to the new datum. What's the value in that? The fact that we want more infrastructure, we want it tied together as tight as we can inside that pipe, that we want to build things as close to tolerances as we can. Everybody wants setbacks on properties. Well, how tightly do I need to monitor that setback? So as surveyors move ahead, and surveyors absolutely will be using the new datums. So we have to be able to incorporate their data into the old thing. So I think it's really a lot about the transformations. And the hardware manufacturers will handle it. Trimble will definitely handle it. I'm sure Esri has their folks working on those abilities to incorporate the new datums. It's the transformations that are going to be the thing we have to pay attention to individually in individual organizations.
Very good. I got involved in GPS back when it was just getting going. I was in the Navy at the time on an aircraft carrier, and so we were out there using the GPS constellations when there were only like 10 satellites in the sky, and so you still had to plot manual celestial locations as well as use the Loran system to do that. So watching the GPS constellation grow to the point that you can just go out any time of the day and collect data is pretty phenomenal. But we're not the only player in the field now. How do you see, or what has been the impact of these other constellations like GLONASS and Galileo and Betelgeuse and so forth been on the products, the capability of collecting better, accurate data? What have you seen as the impact of that? And then what do you see as the future of some of these constellations going forward?
Yeah, we've definitely seen a dramatic increase in fieldwork productivity because of the increased constellations. So that now, like you, when I first started going to collect data, if I was getting 6 or 7 satellites, I was ecstatic because of the data I could collect. And there were issues of going under tree canopy and around buildings, can I get a position? For receivers now, because instead of picking up 4 to 8, maybe 10 satellites, now we're seeing anywhere from 14 to 22 satellites. And that's going to vary geographically where you are in the world. So when I say I'm getting 22 satellites, that's here in the Carolinas kind of area. So what benefit is that? Out in the wide open, it's of marginal benefit. Once I start getting under even suburban tree canopy, whether it's urban canopy of buildings, then the fact that I have so many satellites from which to get a position really increases my productivity. I don't have to wait for a certain time of the day. I don't have to wait for satellites to converge to get better accuracy. I just turn the equipment on and I go collect data. So it's been a productivity gain. There certainly are accuracy gains as well. Because I do have so many more satellites, then I can feel more confident about the position that I'm collecting. And I would expect that to continue to change as other countries start to develop their systems. The United States is starting to launch a new system now. The Block R5 satellites are starting to go up. How soon will those take effect beneficially to the system? What will be the benefits of those is yet to be determined. There are some people who say that, okay, then in 5 to 8 to 10 years with my cell phone, I'll be able to get 10 centimeters of accuracy. We don't really know. We won't really know until they get a full constellation of those satellites and we can start doing testing and things like that. But as we would expect, technologies continue to change, and certainly one of those big gains have been the ability to use multi-constellations. So that now when we talk about our receivers, we don't talk about a GPS receiver, we talk about a GNSS receiver. So a global navigation satellite system is that kind of acronym we use now, but certainly a great benefit of those systems.
So, well, and as I mentioned earlier, everything's GPS enabled or GNSS enabled now. One of the things that came up a few years ago was LightSquared, which was supposed to be a terrestrial broadband wireless network that was going to operate very close, right adjacent to the GPS frequencies. And correct me if I'm wrong, but GPS only broadcasts like 50 watts from the satellites, and they're 12,000 miles in orbit, 11,000 miles in orbit, and then you're going to have this terrestrial system broadcasting at a lot higher power rate. I don't remember what the wattage was going to be, and there was a lot of concern about the impact on GPS and its use. There is a new, I guess a LightSquared restart. I forget the exact name of it. Have you heard anything within the industry about what this new program is supposed to be, or is it been a discussion? Has it seemed to be a concern within the GPS world, the GNSS world?
Sure. I'm not aware of that. Certainly was well aware of LightSquared. I'd kind of forgotten about it, to be quite honest, till you brought it back up. But I remember those days of, it's kind of like the year 2000, the Y2K. Mm-hmm. Everybody had dramatic concerns about what was going to happen, and what's going to happen when, are the lights going to turn on? Is the electric grid going to go down? Not as dramatic, but certainly the concerns were about LightSquared. What's it going to do? Well, I think the FCC kind of finally recognized what was going to happen and put a kibosh on their approval for frequencies and things like that. So no, I haven't heard anything about this new system. Certainly there are concerns. We trust the FCC to continue to monitor those frequencies and as they adjust things around. But no, I haven't heard any of that information. I think it's such a pervasive use of technology now in so many places that I can't imagine an impact would be allowed to be slid through the approval process without somebody raising significant concerns and having that understood in the marketplace. I think we're okay.
Well, and hopefully with the new satellites going up, they're introducing a couple of new, the L5, was it L3, L2C or L1C signals instead of just the L1 and L2 that we had on the old GPS constellation. I also think the wattage has doubled. Is it increased on that? So that should hopefully help overcome some of these concerns if they do implement something like that, and who knows. So is there any other new technologies on the horizon? We see a lot of obvious integration with things like drones and LiDAR with GPS, and we see a lot of benefits with that, but are there any other technologies out there that is being interfaced with GNSS that GIS people need to be aware of that can maybe help them do things better, do more, be more efficient, and whatnot?
Sure. What we're seeing now is a convergence of technologies so that it's the application of GNSS incorporated with other technologies. That's going to be the change. So for example, I mentioned the cell phone. So Trimble's done development now where instead of just using the chipsets in the traditional receiver, the reality is there's chipsets in here that are pretty similar to what you have in a cell phone. So what Trimble's done is built what they call a software GNSS receiver, so that they've put software on a phone that's turned it into a GPS receiver. Antennas aren't very good in cell phones, so what they've done, we do have to use an external antenna, and this is just an antenna. There's nothing magic in here as far as a receiver, it's just an antenna. So I cable this antenna into my Android phone, and then Trimble has software that takes the components of my phone and turns it into a GPS receiver, even down to the centimeter level. And I've seen it myself. My background is in the sciences, so I tend not to believe things until I can prove it myself. And so I've done it. I've plugged in a silly antenna, logged into a subscription, and gotten a couple centimeters on my phone. So that convergence of technologies is what we'll continue to see. Trimble's working on a product called Sight Vision. So that in April or May or sometime early this year, you'll have an interface where you have a phone and interface with something like a Catalyst, and on that phone, out in the field, I'll three-dimensionally be able to see my infrastructure. So here in this conference hall, I can see the carpet, I can see the structure that's here. With Sight Vision, with the kind of CAD infrastructure in the background from as-builting, I'll be able to look in my screen and walk around, not inside the building, but outside, with a GPS feed, and I'll be able to look at the skeleton of what's there. So as I'm walking down the street, I can see, okay, here's where the pipe is buried underneath. I can see that it's buried 4 feet underneath at this point. Or I can see where the fiber optic line is on this part of the sidewalk, or where the water line goes across. So as I'm walking down the street, I'll be able to see that as I'm moving along. We've kind of seen an introduction to that with Google View. Everybody loves Google View.
Yep.
You got Street View. Well, think of taking Google View and putting it in an X-ray machine. So not only now do I see the asphalt, or I see the concrete sidewalk, I can now see what's under that concrete sidewalk, or I can see what's behind that building from an infrastructure perspective. So it's really going to let people take their paper maps, which are only one-dimensional, turn them digital, which we've done already, but now we're going to add a 3D component to it as we're walking down the street. So again, a convergence of technologies is really what we're starting to see.
Well, that's great. I mean, I did a talk the other day on, is your data ready for 3D here at the conference, and I talked about, you can cut somebody's water line, you can cut somebody's sewer line, you can cut somebody's gas line, and they'll live, right? Cut the water line, I'll just go to the grocery store and get water. Cut the gas line, well, as long as you get it shut off, I'm not in danger, okay, I could live for a little while. But you cut somebody's internet, and they go nuts. Oh my God, what am I going to do? I can't Facebook, Netflix, YouTube, whatever, right? So yeah, I think absolutely those kind of technologies are going to be very impactful. I guess in one kind of last question, you mentioned, talking about inside the building, there seems to be kind of a growth into that internal GIS, GPS. I know it's not really true inside, but that, how do you see in that going, in the kind of the integration of literally walking at the door and also being able to kind of navigate inside?
So I agree. We'll continue to see that, both through sensors that are used inside buildings to, again, bounce signals off of to get a location. Because the trick is, how do we figure out a location? So there's things that can do that. There's also inertial methods that have been used for quite a while. So one of the challenges in the industry has been inertial kind of gyroscopes and things. They're kind of big and bulky and heavy, but I think we'll continue to see those reduced in size. So I definitely think that's the next era of positioning, is maximizing usability of indoor systems. I know Esri's working on some indoor type applications, and Trimble has some components that are working on those as well. So yeah, I think we'll continue to see what it's going to look like in 3 years or 5 years, not quite sure, but I'm sure it won't be much bigger than a cell phone that I'll be able to use those technologies for locations. Definitely coming.
Yeah. Well, it makes sense. I mean, you've already got the fitness bands or whatever that track the number of steps you take and all that. So I'm sure it'll kind of build off of some of that technology. Well, I appreciate taking time to talk with me today. A lot of good information. I think our viewers will be happy to hear that. So hope you have a good rest of the conference. It's our last day. So a lot. But again, thank you so much. And everybody, we'll see y'all in the next video.
Thank you all very much.
Good job.
Thank you.